Everyone, this is part 3 and the topic for today is polynomial values. I think before we start on cubic polynomials, as we see in the example, let's go back to a simple one, such as y equals 2x plus 1. This is a straight line, okay? I've drawn the axes here. Let's see if we can draw this line. 1, 2, 3, 1, 2, 3, up. -1, -2, -3, -1, -2, -3, like that. So if you recall, this is the x-axis, and this is the y-axis here. And it's always like that. We never swap x and y when we're doing standard questions. So if we wanted to draw this graph, let's take x to be 0. If x is 0, put 0 in here. You'll see that y will be 1. The y is 1. So this is a point on the graph, 0, 1. So x is 0, y is 1. That would be this point here. There. I do that. Okay, so take another point. X is 2. It doesn't matter what your x values are, but I'm just picking 0, 1, 2, -1. It doesn't matter. So take x is 2. 2 2s are 4, plus 1 is 5. That means that y would be 5. So this is the coordinate, 2, 5. This is a very quick way for drawing a straight line. We only need 2 points, and we can draw the line. So this would be the point, x is 2, 1, 2, and y is 5. 1, 2, 3, 4, 5. So about here. So this is the point 2, 5. This is the point 0, 1. I usually put them in brackets, and then we can draw the straight line down through there. So that's the line y equals 2x plus 1. We're going to do more on straight lines later, but this is just an introduction. So instead of writing y equals 2x plus 1, we could write it as a polynomial. We'll write p x equals 2x plus 1. It's the same thing, except in this case, y is equal to px. So we could just write px here for the y-axis as well. Right? It's very convenient. So for example, we can use this example here of 2, 5. So here we're saying when x is 2, so when we put 2 into our polynomial, we'll have 2 times this number, which is 2, plus 1, which will give you 5. And we can see that's the y value here. So we could say that P2 equals 5. Similarly, what if we had P minus 3? What would that be? So this is telling us to take the x value, minus 3, and put into our polynomial. So 2 minus 3 equals plus 1. We'll get minus 6 plus 1, which is minus 5. So when x is minus 3, the y value, or the value of the polynomial, is minus 5. Okay, we could do that many times and get many points, and then we can draw the line. We can also apply this to this cubic polynomial here, but we won't do the whole drawing of that because that would take too long. Let's go down a bit. So your first exercise, I'll help you with the first one, the first part. Just make some space here. Okay, complete columns 2 to 5 for each of the following polynomials. So in the first column, we want to know what is the value of P1 for question A. This is the first one here. So I want to know P1. So we put 1 into our polynomial. So we have 1 cubed plus 1 squared plus 1 plus 1. Okay? And then we'll get 1 plus 1 plus 1 plus 1, which is 4. So what I want you to do is write 4 in here. So P1 equals 4. And we do that for all of these 4 columns. These ones here, column 2 to 5. Okay? But for column 6, what we need to do now is practice your division again. So we're going to divide your polynomial by x minus 1. So we'll do that down here. So let's review our division. So x minus 1 is being divided into the first polynomial for question A, this one here. So x cubed plus x squared plus x plus 1. So x cubed plus x squared plus x plus 1. What I want to do is find the remainder. The remainder is the number that you'll write here by division. Let's divide. So what times x will be x cubed? That will be x squared. X squared times x is x cubed. X squared times minus 1 will be minus x squared. And subtract. X cubed minus x cubed, 0. X squared minus negative x squared minus negative makes a plus. So that will be 2x squared. Drop down your x, write it there. So now we have 2x squared, and this is x. So it looks like it's going to be 2x. And then we multiply. 2x times x, 2x squared. 2x times minus 1, minus 2x. And subtract. 2x minus 2x is gone, 0. X minus negative 2x will be 3x. Okay, so bring down your 1. But don't stop here. We still have a number on the end here. So we've got an x, we have a 3x. So this looks like it will be 3. 3 times x is 3x. 3 times negative 1, negative 3. And subtract. But then we're going to get 1 minus negative 3, which is 4. That is the number you write in your table here, 4. And look at that, it's the same as this number here. Okay, so you need to do this for each cell. So in the first columns, 2, 3, 4, 5, you need to do by evaluating. 6, 7, 8, 9, you do by polynomial division. So if you're using a tablet, you can do your working here. Then when you want to do another question, just go and rub it out. You can leave 1 or 2 there for me to look at, okay, in this section here. So you don't have enough space actually to do them all of these ones in the space. So just do a couple and then show me your working. But then you can write the numbers in here. Okay, so what you do after that, after you've filled in the table, we try to answer question 3 here. So look at your results in the table and see if there's a quick way you can find the remainder. Okay, so I want you to compare these columns here with these columns here. And I want you to see if there's any relationship between these two sets of columns. So 2 to 5 and 6 to 9. And I think you're going to find something happening here interesting. Okay, so if you've done your work correctly in that table, you should be able to write down what goes here. Okay, this is very important for the next section of work. So let's try to do that properly. And then we'll go on to the remainder theorem after you've done that.